Hello. In this video, we're going to talk about a particular application of peak detectors, which is the case of an envelope detector. An envelope detector is a circuit that is used sometimes in communication circuits, in particular in the demodulation of AM or amplitude modulated signals. So if we look at the amplitude modulation scheme, we typically have an input signal, which is a low frequency speech signal, and we refer to it as the input signal, the modulated signal, or the information signal. It is the signal that's carrying the information. And we would like to transmit this signal over a long distance, but we would like to do so without incurring heavy losses in our signal. And in order to do that, we would like to have a high frequency signal. And so the trick that we play is we sort of ride this information signal on top of a high frequency carrier signal, which contains no information. It's simply a high frequency signal so that we are able to transmit it over long distances without too much loss. And so we modulate the two, and what we end up with is a signal that looks like this, basically the high frequency carrier signal, which is riding on sort of a low frequency envelope. And so this signal still contains that information signal if we are able to extract the envelope. And that's exactly what we're going to do at the receiving end. We will have a demodulator whose job is to extract that envelope so that one can recover the original information signal. One can use a peak detector for that. And essentially what will be happening in that case is that you will have the capacitor that will be charging up to that peak value, first peak value of the information of the modulated signal, I should say. And then it's going to start discharging slowly, but then right after we're going to have another peak. So the capacitor is going to charge again, another peak, so it's going to charge again, it's going to discharge a little bit, etc. And so throughout this process, you can see that what we will be extracting is roughly the envelope, with a few bumps, and so we probably will want to run it through some kind of filter to smooth it out a little bit. But in essence, that's what's happening here. That's what an envelope detector consists of. It's simply a peak detector. Now we do have one additional constraint with respect to the original peak detector application we learned about, because in that case we wanted to hold a steady value for the peak value of the input voltage. In this case, we not only want to do that, but we want that when the input voltage decreases, we're going to be able to follow that decrease. And so our time constant must be such that the capacitor is allowed to charge and it doesn't discharge heavily as my input signal is building, but then it's able to discharge when my input signal is decreasing. And so I will want, as before, I will want my time constant for my circuit to be much smaller than that of my modulating signal or input signal, just as we did with the peak detector, but we need that time constant to be greater than the period of my carrier signal, and again, because we wanted to be able to follow that envelope. So this will be one particular application. It's not necessarily a new type of circuit, even though sometimes it is considered a different type of circuit from a peak detector. But it's simply, either way, it's a peak detector with some additional constraints. Thank you.